Hi everyone, welcome to week 3 of your technical math course. This week we're going to be covering chapters 5 and 6. Chapters 5 and 6 are about linear equations and ratio and proportions. And so they do have a lot of similarities because in both cases you're going to be doing some solving of problems. So you're going to actually solve an equation to find an answer, a solution to something. And these techniques are going to be techniques that you're going to be using going forward for other types of problems. So it's really important that you understand these topics this week and that you reach out to me if you're having problems or questions on them. So the first thing I want to point out to you in chapter 5 is it's really important to understand the language, the topics and the actual what are we talking about. So the first thing is the difference between an equation and an expression. An equation has an equal sign, an expression does not. So that's the big thing. If you don't see an equal sign, you're not talking about an equation. If there is an equal sign, then you do have an equation. So that equation means that the two quantities are equal. So one side is equal to the other. And I like to think of an equation as a teeter-totter. So when we start getting a little further along and we talk about solving a linear equation, keep in mind that it's like a teeter-totter. So whatever we do to one side, we have to do to the other to keep everything even. So keep that in the forefront of your mind, that in an equation, those two quantities on either side are equal. So a solution to an equation is something that makes the variable, a value that makes the variable make the equation true. So you can have a false equation or a true equation. And if you have a variable in there, the idea is you want to make the value of that variable correct so that the equation is a true statement. Couple other very important concepts that they're going to talk about at the beginning of this chapter is what is a variable. And a variable is just any letter that's used to represent an unknown. Now, a lot of people use X, and that's fine. If that's what you're comfortable with, you can continue to do that. The thing that I like to do, though, is to use the letter N. And the reason is because it doesn't get confused with multiplication. The letter X can be confused with multiplication in a problem, and we don't want to do that. So that's why I usually use something other than X, and N is just kind of my go-to letter that I prefer. Factors are anything that are multiplied together. So they could be a number, or a number and a variable, but anything that is multiplied together, those are considered factors. And then terms are single quantities or products of quantities or quotients of quantities. And I've given you a few examples. So the letter N is considered a term. It's just a single quantity. However, 2n is also a term because it is a product, 2 times n. And then finally, I've got a combination here, 2n divided by 3. So these are quotients of quantities, a top number, 2n, and a bottom, 3. The other thing I want to point out is the fact that you can show multiplication in any of these three ways. So 2 times n, or 2 right next to the letter n, or 2 and then parentheses n. All three of those things say the same thing, 2 times n. Okay? When we talk about a coefficient, that's going to be the number part of a term. So if you see 2n, the coefficient is 2. And again, any quantity where you have multiplication going on is considered a term. So it doesn't necessarily have to have a number in it. Here's an example. X times Y is one single term. All right. So if you look at some of my examples that I've got here, there's a few examples here that are different than what's in the textbook, but these this is an expression because it does not have an equal sign, and the terms are all those pieces of the expression. So you can see that we have a total of 4 terms: 14x to the third minus 6x squared plus 3x and a plus 5. All 4 of those things are considered expressions. Now, the coefficients of each of these terms of the expression, in this case, the first term has a coefficient of 14. The second term has a coefficient of minus 6, excuse me. The third one has a coefficient of 3, and the last one has a coefficient of 5. So being able to identify those things are going to be very important as you're going through this particular chapter. The other thing you're going to be looking at, and this is also in my announcements, is this table that shows some of those key words and phrases and what do they mean. So we have a lot of words that mean add things together, right? We have the word add, but then we have total, plus, more than, all of those things. So I've given you just some key phrases that you're going to be using as you translate things into algebraic expressions. And that's my next slide as well. So you can take these expressions and write them out, the phrase, and actually write them out in expression. So go from word to expression. You can also do the same with an equation, looking for those key words. Equals or is are the ones that indicate, obviously, equals. And then a little bit further in the chapter, you're going to go through, and I'm going to kind of skip through some things here, but you're going to go through how to actually solve an equation. So we're going to simplify both sides, getting rid of any parentheses that we might have, combine like terms, and then we're going to use that whole idea of adding or subtracting to both sides to keep that thing, quote, equal. So let me give you an example of what I mean by that, and let me find a quick, easy one to show you. So, for example, here's one for you. Okay, so this is the equation that we're working with. X minus 6 equals 18. In order to get the x by itself, we have to undo whatever we're doing to it. So the opposite of subtracting 6 is adding 6. So you'll see down here, that's what we did in our second step. We added 6 to both sides. And the reason we do it to both sides, again, that whole idea of a teeter-totter. We want to make sure that everything stays even. Once we do that, you'll see that the second or the third step is going to be x plus 0, because a minus 6 and a plus 6 is 0. And then 18 plus 6 is 24. So our solution to this equation is going to be 24, x equals 24. So we go through those processes in chapter 5. And then we're going to do some similar things in chapter 6. Chapter 6 is all about ratios. So a ratio is a comparison of two quantities. So maybe we're comparing apples and oranges, or boys and girls in a class, things like that. So here's an example. We can write it in 3 ways. We can write A to B, or A colon B, or A over B in a fraction. And what you're normally going to be seeing as we start working with a proportion is you're going to see us writing these ratios in the fraction form. Okay? So here's an example of a ratio. In an algebra class, there's 15 women and 17 men. So the ratio of women to men is 15 over 17. So just a quick example of how to write a ratio. And then we can take that ratio and we can write it in with another ratio in a proportion. So it's another type of an equation, but it's 2 ratios that are equal to each other. So let's take a look at an example. Here are 2 ratios that are equal to each other. 5 is to 12 as 30 is to 72. So we can write them as 2 fractions that are equal to each other. And therefore, if we have a missing piece of a proportion, we can solve it. So here's an example of a proportion, and we can find that missing piece. So in this example, we have x over 13 equals 6 over 39. And this is what most people refer to as cross multiplication. That's how we solve a proportion. So you can see we took x times 39. So there it is, 39x. Keep that equal sign in between. Remember, it's a teeter-totter. And then 13 times 6 on the other side. We're going to go ahead and do that multiplication. 13 times 6 is 78. Then we have to get rid of the 39 that's with the x. Well, what are we doing? It's x times 39. So the opposite of multiplying by 39, right here, dividing by 39. So we divide both sides by 39, therefore x is going to equal 2. So that is the section on solving a proportion. As you go through this week's material, there's a ton of stuff here. So remember that that's what I'm here for. If you get stuck on anything, please make sure that you reach out to me for assistance, and have a great week.